furnaces are custom designed to control the flow of heat and handle the load needed for the process they service. The one shown here is one of the more common furnace designs.
This type of furnace is shaped like a house and is called an A-frame or cabin furnace. The inner walls of the furnace are lined with a material that reduces heat losses and reflects heat back onto the tubes. This material is called a refractory lining. The burners in this design are located on the floor. They can also be placed on the walls or the arch of the furnace. The air required for combustion enters the furnace through air registers located directly under the burners. The section directly above the burners is called the firebox. The firebox contains the flames in the furnace and does not let any unwanted air into the combustion zone. The radiant tubes are located in the firebox of the furnace. They're in direct line with the burners, so they receive most of their heat by radiation. The section of tubes above the burners is called the shock bank. These tubes receive both convection and radiant heat. Above the shock bank is the convection section, sometimes called the economizer section because it extracts heat that would be otherwise wasted. The tubes in this area are heated by the hot flue gases before they leave the furnace stack. The process flow is sent through the tubes and is quickly heated. It then flows out of the furnace to other process equipment. The tubes which carry the process flow are generally divided into passes or coils. If the passes are balanced properly, each pass receives the same amount of process flow and absorbs the same amount of heat. After the process flow is circulated through the passes, it is rejoined at the outlet. In the stack of the furnace is the damper. The damper adjusts to control the flow of hot gases out of the furnace. This upward flow of hot gases is known as the furnace draft. Now let's see what happens in our simple model of a furnace. The air registers are open to provide the correct amount of air for combustion. The damper is adjusted for the correct amount of draft. The feedstock is pumped into the furnace and divided between the passes. After circulating through the tubes of the furnace, the feedstock is rejoined at the outlet of the furnace. There is a target outlet temperature for the process flow, and this is used to determine the amount of fuel going to the burners. In an automatic control scheme, the outlet temperature is monitored by a temperature controller, which controls the flow of fuel to the burners. In order to increase the outlet temperature, more fuel is burned. To decrease outlet temperature, less fuel is burned. The furnace draft is important because it moves hot flue gases out of the stack and draws fresh air through the registers to the burners. The type of furnace we've discussed so far is a natural draft furnace. It's given this name because the draft occurs naturally due to the fact that hot air rises. The rising flue gases cause the pressure inside the furnace to be slightly lower than the pressure of the atmosphere. This lower or negative pressure is what maintains the draft through the furnace. Other furnaces use fans to maintain a draft. In an induced draft furnace, a fan is located in the flue gas ductwork to the stack. This fan pulls the flue gases out of the furnace to maintain an adequate draft. A forced draft fire heater uses a fan to supply air for combustion. Even though the combustion air is under positive pressure, a negative pressure is maintained in the rest of the heater by the natural draft of the hot flue gas. Fired heaters, which use both forced and induced draft fans, are called balanced draft furnaces. In this system, a forced draft fan supplies air for combustion, while the induced draft fan pulls the flue gases from the firebox to maintain a negative pressure in the furnace. Preheaters are used on some fired heaters to reduce fuel consumption. These systems use the heat carried by the flue gases, which otherwise would be exhausted to the atmosphere, to preheat the air for combustion. This conserves energy because the combustion air enters the furnace at a higher temperature and therefore requires less heat for the combustion reaction. An essential piece of equipment in any fired heater is the burner. The function of the burner is to mix fuel with air in a manner that will maintain stable and continuous combustion. The design and operation of a burner will vary depending on the type of fuel that is being used.